So we're going to look at 2D collisions. We're going to look in both methods, so trig and sine cosine law. We're going to add one more component to it. We're going to add a third dimension to it. Okay? Or not a third dimension, but a third layer to it. So here we have an object with a total mass of 15.7 kilograms sitting at rest when it explodes into 3 pieces. Grease. One piece was with a mass of 4.7 kilograms moved up and to the left at an angle of 22 degrees with a speed of 28 meters per second. A second piece with a mass of 5.2 kilograms moves down and to the right with an angle of 27 degrees at a speed of 20.7 meters per second. What is the velocity of the third piece after the explosion? So this just needs to be paying attention to our information before and after. So we have mass. I know. We have mass before of mass 1, 22 degrees. One piece with a mass of 4.7 kilograms. This one here is 5.2 kilograms. Okay, and it's asking us what is the velocity of the third piece after the explosion. So, before, actually, I'm going to move this over. And after. So our before pieces of information before, we had a mass of what? 15.7 kilograms. Okay, and we had a velocity of 0. So that means that our momentum equals 0. Okay, and so then our P in our x direction is 0 because it was stationary. I'm going to write this backwards. And then our P in our y direction, 0. Because it was stationary. So after, we have a bunch of information we can write down. So we have mass 1 is 4.7 kilograms. Its velocity is 28 meters per second. And so its momentum is, let's say 22 degrees north of west. And so its momentum is 131.6. Okay, we have mass 2 is 5.2 kilograms, and velocity 2 was 20.7. And so our momentum 2 27 degrees, oops, east of south. Because it's looking at this angle here. So this is east of south. And then we have mass 3. Does it tell us?
You can figure it out.
How do we figure it out, Jaden?
5.2 and take 15.7 and minus it by the number you got.
Exactly. We had a total mass before and we have to conserve mass.
5.8.
and it's asking us to find the velocity. Okay? So, where do we go from here? Working on what you just worked on, what is it that we need to solve? We're doing trig, remember? We need to find them in the x's and the y's. So you need px1, you need py1. So we have 4.7. Let's do this a little bit differently. You're going to have the cos of here, right?
Okay, just wondering.
We have this. This is P1. This is P2. And this one here is P3. We have this information and we have this angle. And so X is adjacent to the angle. So adjacent is cos. So you're going to take the cos of 22 degrees and you're going to multiply it by 131.6. When we're looking for the y, it's opposite of the angle. So you're going to take the sine of 22 degrees times 131.6. And you're going to repeat said step for Mass 2. PX here. So what do we get for values? We'll just solve this one and then you guys can go, okay? We're almost done. What did you guys get for values?
PX1 is 122.017. PY1 is 49.298.
For which ones? Some of them are negative and some of them are positive. Which ones are negative? What? PX2 is not negative. PY2 is. There's also another negative one that you haven't identified.
That's PY1.
PY1 is positive.
Wow.
Right? X is going this way.
Ooh. That's, yeah.
Okay? Do we have values for x2 and y2?
X2 is 95
x2?
Oh, did I do it wrong?
Sign, right? Because here's x, opposite.
Oh, yeah, I did it. Oh, so it's 48 point. Yeah, I did it wrong.
Jeez Louise, Pop, just get out of here. Here comes a wrap.
If my door is closed, it's because I'm busy. And why?
95.908, I guess, was rounded.
No.
And what do we know about that one? It's negative because it's in this direction here. Okay, so it's asking us what is the velocity of the third piece after the explosion. So we have P x3 and we have P y3 is what we need to be looking at. So we have P x total prime. We have P y total prime. And we can figure this out. Let me just back up. We have the sum of the P of x before is equal to the sum of the P of x prime. We have the sum of P y is equal to the sum of P y prime. Right? So we can call this one, we'll go 0 is equal to, what do we have? X. Negative 122.017 plus 48.867 plus x3 prime. And then here we have 0 is equal to 49.298 plus negative 95.907 plus y3. Once you figure those points out and you can figure out your total momentum, then you can figure out your velocity. So your x prime is equal to what?
Negative 73.15.
Okay.
Odd.
I got positive 2.
Okay.
You forgot the 2 for 122.
Yeah.
Yeah.
Okay, and y?
Oh, yeah, I forgot to put going down.
And then your y is equal to 46.6097.
So this gives you an x value and a y value. And what you're going to need to do, come back tomorrow with this information, is you can now figure out your momentum in the x, you can figure out your momentum in the y, and you can figure out this momentum. This is what you need to figure out your velocity. Okay? Does that make sense? You have to draw it tip to tail. I didn't draw it tip to tail.
Figure out that hypothesis and then figure out the velocity right there.
Yeah.
Yeah.
Okay? So have that ready to go for tomorrow morning because that's where we'll start.